And as I always say that we just don't want to go to the protocols and methodologies, just want to make you aware how the world is moving and what all we can do as a gynec. As a gynec, our biggest challenge is sperm preparation. And in case you look at what the government has done as per the ART Act and regulations, which came on 7th of June of 2022. As per that, now any gynecologist can start an IUI clinic. They have not given them specified that they should have a technicians or an embryologist there. So I think they can do it themselves. You're all very busy people. I've interacted with large number of you. You're so busy that I feel humbled. I feel that I'm busy. When it come down to me, when I talk to you, I feel humbled at how busy you are. And one thing which you don't want to do is doing semen preparation. That's the reason that we are actually handing over our specialty to multiple other people who are doing it better than us. But I don't think that's the right attitude. But you say we don't have any time. So let's see, can we save some time? Can we do it ourselves, and how we can do it? That'll be the whole journey of the day. So this is looking at the semen sample, we're trying to look it under a microscope and trying to get some information. And then probably that's the way the sample comes to us in the clinic. And I think we have all learnt about semen analysis multiple times. So before I move ahead, I'll catch one volunteer from you. So I'll catch whom? Whom do I see on the screen whom I can catch? Any friend who's gonna speak about what is normal semen analysis quickly in around 20-30 seconds? Any one of you? Any one of you can tell me what is normal semen analysis? If no one volunteers, then I think I'll give it to Ninka. She's the guest of
Good
honor.
evening, sir.
Yeah, Farhana.
Sir, this is Farhana, sir.
Yes, Farhana.
Semen analysis have a microscopic examination and macroscopic examination,
Can
sir.
we have camera on, please, Farhana? Can we have your camera on if you don't mind, so that we all can see you and clap for you? Actually, you have taken a big leap. Menka bach gayi, so on to Farhana.
Yes.
The camera can be on. We'll be very happy to see you. Otherwise, it's okay. Please carry on. Yeah, that's great, Farhana. Great. Super. It needs a lot of courage and guts to do this, what you're doing. And I think
I'm an embryologist student, sir. I have completed my BSc Honors Reproductive Medicine and Embryology in Savita University, sir.
okay.
Semen analysis has microscopic examination and macroscopic examination, sir. Microscopic examination has sperm concentration, vitality, morphology, and also some other parameters, semen parameters. And macroscopic examination has pH, volume, color, odor. All this examination comes under microscopic examination, sir.
Okay. So what is the normal count of semen sample? Anyone? What is the normal count?
15 to 20 mul.
20 million.
15 million,
15 million
per ml and 39 million per ejaculate.
So
15 million per ml, ma'am.
no.
15 million per ml.
Guideline, it has become 16 million per ml.
16 million in the new guideline. It's 16 million per ml.
16 million per ml.
16 million per
4%
ml.
normal morphology.
12 million. And how much is the normal volume?
4%.
1.4 ml.
4 ml. Great. Vitality?
More than
34%.
54% live.
4%.
54.
Great. I just wanted to get some involvement of all of you, and I think we know about how to analyze the semen sample, but let's go look at coming to sperm preparation. So I always feel that before, in normal women, sperms are also being prepared in the body of the woman by multiple ways. Whatever we do outside, the body does it inside. The first barrier is the vaginal pH, which will eradicate all the bad sperms. the sperms have to ascend. They have to go through the cervix. There we have a cervical mucus
क्या
plug.
देख रहे हो ये क्या देख रहे हो
The cervical mucus plug won't allow sperms to move in. Then they'll go to the uterine cavity, which will again have an altered pH. And then we'll have the uterotubal ostia, which will keep pumping these pumps back. And when they relax, they can just move in. And when they move in, barely few 10 or 20 or 100 sperms are able to move in from few millions which have come to the vagina. So I think these sperms are able to, they can actually, they can smell an egg. Maybe they are able to smell an egg. They are able to, they have chemotaxis, rheotaxis, thermotaxis, and they're attracted towards an egg and they move up. And as they're moving up, the uterus will keep chopping the sperms into various compartments. It won't allow them to reach, though it will be attracting them. This one picture, standard picture I show to all the batches. I'm showing to you, probably some of you again. So when we start, we are starting with few millions of sperms from the ejaculate. And by the time they reach the ampulla, when they'll fertilize, there are few hundred sperms. Maybe 100 sperms are able to reach here to fertilize an egg. This is what we are seeing here. So mean that they're getting eliminated at every level. Every level, somebody is eradicating these sperms. That happens in vivo, in the body itself. But now we're talking about a fertility management. So here we are trying to do things in vitro. And what happens in vitro? In vitro, we've got various techniques by which we can do the sperm separation. And today, let's see what all are the options available to us. And what all options there's a busy gynec in you. There's a busy gynec. And it's busy gynec can pick up an easy technique, and a busy embryologist can pick up a more efficient technique. This is what we are trying to. And then I'll take you to the basic fundamental. The one thing which we all hate is semen preparation. We all love embryology. We all love to do things in the laboratory. But when it comes to microscopy, when you talk about doing a microscopy or we want light and other things, we are very much scared of not doing it. So I want to ask you, what is the chamber depth? What is the chamber depth? Chamber depth in a case of a macular cell or
10
any
microns, sir.
10 micron,
10 microns.
10 micro.
10 micron 10
micrometer. Remember,
micrometer
that's the right answer.
10 micrometers.
Micrometer. Again, I want to ask you, can someone tell me the chamber depth in a glass and slide method?
20 micrometers, sir.
20.
20 micron. 20 micron. Very good. So this is what I wanted to hear from you. 20 micron. Now, our main aim is removal of spermatozoa from the seminal plasma. See, what we get is an ejaculate, and ejaculate will gradually liquefy, and as it is getting liquefied, and there's a time when it's getting liquefied, what we will do is that we will try to, after it has happened, we'll try to separate seminal plasma from what? From the sperms. So we want to take out everything but the sperms. And the sperms we will resuspend in a media. In a media, we can take any media like this, which is an HTF media. I'll be showing to you as I move on. Today I'll give you a lot of live demonstrations, so you are able to remember things. So first technique which we have is called sperm washing. Sperm washing. So we have to wash the sperms, and so we take the semen sample and try to wash it. And how does washing occurs? In the semen washing, we will the ejaculate which you get, the ejaculate is having sperms. It is got plasma, seminal plasma. It's got immature sperms. It's got WBCs. It's got a lot of debris. So we want to wash the sperm and we only want to get the sperms out and rest everything we want to reject. This is about the whole process and we call it sperm washing. Simple method of sperm washing where we take the liquefied semen sample, as you can see here. We take liquefied semen sample here. It may be a surgical aspirate doing TISA, PISA or whatever you want to do, or it's a simple sample which is liquefied. And then we mix 1 to 1. So we take the semen sample, probably we take this bottle of semen sample and we mix it with equal volumes of the washing media. And what does the washing media contain? Anyone? What does the washing media contain? Who will tell me about the
Hippies and mops material.
what is HIPPIS? What is HIPPIS?
Propane sulfonic acid.
Hydroxy,
Sulfonic acid.
ethane,
Buffering media.
propane.
Sulfonic acid.
Correct. So this is called HIPPIS. So what does the HIPPIS do? This basically an HTF media, human tubal fluid media, lookalike. It contains HIPPIS and buffer. So what is the quality of a buffer? When you talk about the buffer, what does the buffer do?
Maintain the pH.
That's fine. But maintain the pH. But this media, do we have to equilibrate it or we don't have to equilibrate it?
No need to
Don't need to, don't have to equilibrate.
by heating.
Only heating, no gassing.
So इसको क्या करते हैं? What is the difference between embryology medias and these sort of medias?
It
Only
needs
heating.
hippies do not need incubation, CO2 incubation.
Charging, don't need charging.
If you incubate it, what happens?
Charging of the
In case you incubate, what happens?
Bicarbonate.
Proteins and degenerate.
Then HIPPIS will degenerate.
Degenerate proteins.
HIPPIS will degenerate. So just know that we don't work on the HIPPIS buffer media in terms of we don't work on HIPPIS buffer media is only to be heated. It's only to be heated, but the bicarbonate medias are always.
Heated and charged.
So now we have to wash. So we mix up the semen sample with this, and then we try to centrifuge it, and we do it in terms of RPMs in our country. So we are normally doing 1200 RPM, 1200 RPM, which we do. As I told you that 1 G is equal to how many RPM approximately?
4 RPM, sir.
4 RPM approximately. I told you this. So 1 G is equal to 4 RPM. So it becomes 1200 RPM. 1200 RPM. So 1200 RPM means that we do it around. We are doing it at 1200 RPM, and we are using not 20 minutes. We never go more than 10 minutes. So we say first wash, in case we are doing any washing, basic concept is that first wash is equal to 10 minutes and second wash is equal to 5 minutes. Simply, simple funda of simple washing is there. Now I'd like to ask you, what is a supernatant? Padma, yes, you want to say something? I'd like to take your query. Padma Dinesh. Padma, okay, fine. They're probably by
RPM is totally dependent on sample viscosity. Is higher sample viscosity and higher centrifugation.
No.
Why the sperm cell damage could be possible?
I'll come to that. I'll come to this, but abhi I'm telling simple statement I made that we never centrifuge more than 10 to 12 minutes in the first wash and around 5 minutes in second wash. I'm giving you one simple standardized method, and probably I'll tell you not to centrifuge at all in some time. In case of centrifuge, the people who have come to us for training, they know that they'll never centrifuge when they go back. They don't centrifuge. So here the message is that we centrifuge for 10 minutes or 12 minutes, not for 20 minutes. What I want to give you, because all the books are writing 12 to, they write 15 to 20 minutes. So that we should not be doing. And there is no concern of viscosity. What I'm telling you here is very standardized method. Let's not create a situation which is a complex situation which never occurs. In our whole life, we have never, when you mix a semen sample with a media, it becomes diluted. And any sample which is have got a bad agglutination or highly viscous sample or a non-liquefied semen sample will become watery only. So there is no question of our rating the sample by viscosity, but once you dilute it with the media, it will become watery. Am I right? Anyone having any problem?
Sir.
Or any problem in this?
No.
Agreed. So now, what is a supernatant? I want to ask you. Who will tell me what is a supernatant?
After centrifugation, the aliquot which is above the pellet is supernatant.
Ah. So what does supernatant contain?
It's mainly seminal
Seminal plasma,
So can we,
Fluid plasma and fluid
so can we,
debris and seminal plasma.
can we use supernatant for
Superintendent.
yes.
no
No,
No.
it
Superintendent
can't
remains
pallet.
the dead sperms and waste material of is removing the superintendent and mortality sperms is in down, sir.
Supernatant has to be discarded. Just remember that supernatant has to be discarded. You be like in a washing machine. If you use washing machine, like I always compare cement preparations are akin to using a dishwasher at home or a washing machine. A simple example I give is that once we are once we are washing once we are washing the things, what happens? That the duct will throw out the soap and the dirt. That water, fresh water goes in, cleans, and the dirt goes out from our clothes. Same way, when we wash a cement sample, just simple fundamental you know is that supernatant is that dirt. Supernatant always has to have to be discarded, and any pipette which touches the supernatant has to be discarded. So there are two pipettes available, or you may take three pipettes. In case a pipette touches supernatant, that pipette you shouldn't use to handle fresh media because pipette will get coated with the. So मैं आपको कुछ fundamental बता रहा हूँ. Simple fundamentals. Don't make a mistake. And probably I'll tell you in some time, don't do it. We won't do it at all. We'll go to some newer technologies. So Rajkumar, RK, are you with me? Rajkumar Lohar had a query. So
Yes, sir.
clear, supernatant has not to be touched. We never touch
Yes,
a
sir. Supernatant is the same like debris and wastage fluid material.
infectious material. So the pipette has to be discarded.
So it has been to discarded from main sample, pellet sample too.
Absolutely. So it should never touch the palate and never touch. We have to discard super. Okay, great. So Pella fundamental which are given to you that when we wash, the centrifugation speed should never go more than the RPM. Should not normally cross 1200. And then, and the second is that we don't centrifuge more than 10 minutes in any for the first wash. And what does the pellet contain? So can someone tell me what does the pellet contain? Anuradha is right, but in when we are doing a simple spin, that time the WBCs may also come to the pallet. That has happened in the pallet in a double wash. So in this condition where we are doing spinning for the only spinning and washing, only washing we are doing, here there is a high chance that our pallet may contain sperms and WBCs also. This is what we have to assume. HTF media, standard HTF media which we use, and this HTF media works very nice when we're working, and it's only for washing, and it's to be stored between 2 to 8 degrees centigrade. That's all about HTF. Sometimes you go to double density gradient medias, which is say 90 and 45, and then we use HTF along with that. So 90 and 45 will work something like this. So allow me to just unshare my screen with you, and I think let me go to the speaker's view, and I just want to show you how these media they look like. So just give me 10 seconds. Here I am. What we have here is a simple HTF media, and you've seen it many times. When I shake it, it forms a lot of bubbles. Why?
ROS.
Contains protein.
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 In case I have this media with me, I just shake it, and you'll find a lot of froth coming.
It
It's the
is
proteins.
human serum albumin is there.
Yeah, very right, very right. So we have got. I hope Mohit, you can see, you can all see what I'm doing now. So we've got an HTF bottle here. We've got gradient. Either we use only this one we use, only this one we use, or we use a gradient media. Gradient can be 90-45 or 80-40, depending on which brand we are using. Gradients also come in such plastic bottles, then which can be 80-40. From some companies make 80-40. Some companies make 90-45, and HTF remains static. We're using a lot of these medias. This is a wash media. So, washing media can come in a plastic bottle. It can come in a plastic bottle like this, big bottle of 6 ml or 5 ml. It can come in a 5 ml vials, or it can come in a vial like this, which we can, we can take out some amount, and then we can, this one once you break, we can't use it. But this one probably for one day you can use it more. We just open it from here, and then we, like a syringe, we take out the media which you want to use. So this one is a nice media. All medias are good, and this media is this is normally, it contains 4 gram per liter. It contains 4 gram per liter. In case you can watch it, it contains 4 gram per liter of albumin. So this is a way 4 gram per liter. Can you watch it? Can you see this? It's 4 gram per liter of albumin. Nice one, and you can use, it's got phenol red in it, and phenol red is an indicator. And along with this, they also give, companies give like these vials only, which you can open and utilize it. And they all come in 1 ml. So this is 1 ml vial. Just remember that your density gradient medias are always in 1 ml. Never forget. Double density 2 ml. HTF 5 ml. Double density is always 1 ml each. Never forget this. 1 ml each. 1 ml each. And sometimes they say 1 ml gradient, lower layer. Can you watch it? Lower layer? And they write upper layer also. Upper layer also. And other people may not do this, and they'll give you a vial like this, and you have to know how to use it. So now the catch here, which I want to show you here, is very important, is when you have got a double density, it will be 1 ml vial. And when you go to a double density, when you go to a single density, it will be a 2 ml vial. That's all I want to. It's meant to just make you recapitulate what we are learning so that you don't forget. I hope all of my friends are clear about it. All clear to everyone?
Yes, sir.
Yes, sir.
Great. Just for recapitulation, the classes are meant for just having a recapitulation of what we have learned till now. Any doubts, feel free to talk to me now. Now we are at number of 350. 350 of you are here. So just feel free. I'm with you. Just want to do it properly. But just get involved with the thing. So this is, we are using a small pipette here. We are adding equal amount of media. And then the simple procedure, the media is being put inside, and then we are mixing it, the media and the semen sample. This is what we have. We load it in the tube, we balance in a centrifuge machine. Finally, we do it for 10 minutes, as I told you. I normally don't cross 10 minutes for the first wash. And then we get this pellet here. ये क्या चीज है? What is this?
Supernatant.
Very good.
Seminal plasma, sir.
Yeah,
Pellet.
this is called
Pernatant.
great. So
I think
I'm done. I'm done.
this is a debris coming from the sample.
Yeah.
Debris. This is
So
deeply not
This
pellet.
is
this is the pellet. This is a pellet,
pellet.
and pellet will have good sperms. It can maybe having bad sperms. It may be having leukocytes. It may be having WBs because this is controlled. इसमें control ही नहीं है ना. It's spin कर दिया ना हमने. So some you may get many multiple things here. But the pellet, how will the pellet? Now again question. How does a pellet of a plain simple wash differs from the pellet of double density wash? Anyone?
This is from singles.
Yeah, Shravani, how are you?
I'm fine, sir. Missing you a
How?
lot.
I also miss you guys. How's your Nagpur doing? AIMS Nagpur? Lost you. So great. How does a pellet of a single of a plain simple
Yeah,
wash?
we have started our case.
हो गई है तेरी आवाज नहीं आ रही बेटा तेरी आवाज नहीं आ रही है. So let's connect. So the how does a pellet of a simple wash differs from pellet of a double density? That's what I want to ask you.
It is a thick palette.
Quantity will be less.
Quantity will be less. Okay. What more?
But it will contain
More
good sperm.
clearer.
Clearer.
Basically,
Acidic.
the number of
Good
WBC
sperms,
will not be there in double
Good
density.
morphology will be there in a palette of double.
Agreed. Geeti, how are you?
In pellet,
Fine, sir.
we
How are
have
you?
good sperm, good motile sperm.
Good. Fantastic. So just want to tell you that there is something called supernatant, something called
Pure,
pellet. Yes, Abdul.
pure healthy sperm isolated.
I think the problem in this sample all containing all contents of tube is mixed. Single first layer of gradient, second layer ensemble, all of them is mixed together. There is something wrong during the process this sample.
No, this is not gradient. This is simple wash.
simple wash.
Okay, that's good.
Abdul,
This
this
is
is
my
not a
this is my
gradient.
default. Sorry.
No problem. It's a
Okay.
gradient nahi hai, Abdul. Gradient is gonna come in some time. Okay.
Mhm.
So this is simple
Okay.
wash. But he had a good observation. He's an embryologist. He's got good observation. So this is not. I have not drawn the columns here till now, and now this is a palette, and then it goes on. Now I want to ask you. I'm just giving you some take-home messages. For my for a C2 batch, I would have spent around I think 18 hours on andrology minimum 18, 19. Then hands-on again 10 hours we do microscopy. But for everyone, just know
Sir,
that yes.
I have a doubt.
Tell your name, madam, and then you ask the
Sir,
doubt.
I'm
Tell your name.
Farhana, sir.
Farhana, yes, Farhana. Ask.
Sir, can centrifugation can cause DNA fragmentation?
Yes,
Yes.
it can cause multiple problems. So I'm coming to this only, Farhana. This is what I want to cover here now. Is centrifugation detrimental to spermatozoa?
Yes.
Right?
Yes.
अब इस पर आ रहा हूं मैं. Farhana, I take your query now. There itself. See, when we spin, our sperms are going. They spin. I assume that we are having, say 5 ml of the column, assumingly, and then we've got this is the bottom of the tube. So 5 ml means this is 5 ml, and this may be say in centimeters or in millimeters, a particular length. Sperm is barely 75 micrometer. The range can be between 50 and 60 micrometer, not 75, sorry, it's 60 micrometer. And sperm has to come down from this whole length, this may be around 4 to 5 centimeter, and come down and hit this. So when the sample is good, the sperms can move away. When the sample is bad sample, bad and good sperms just start cutting each other. And then there can be plasma membrane injuries. So there are plasma membrane injuries. And these injuries will do what? What will they do? ROS.
Increase of growth.
Yes.
ROS.
So sperms they start cutting each other. Example, if you visit people who drive good cars, luxury cars, those cameras they stop by themselves. Like the cars will halt by itself. The cars won't allow you to change a lane. And they may wake you up, give you an alarm, wake up, you're sleeping, and will take you to the side by itself. Cars take over the control. But same
ADAS.
But same car, in case you ADAS, yes, very right, ADAS. They got 360-degree cameras all around. Car controls you, not you. But same car, in case you go to Jama Masjid in Delhi, my favorite place to have chaat, and you must visit Jama Masjid in case you come to Delhi, in case you want to have good non-veg food, where there you may even take a tractor or you take an aircraft, somebody will bang you. वहाँ का मजा वही है कि somebody will keep banging you, whichever car you take. So when the sperms are unhealthy, the rickshaw walas, auto walas will keep banging you. So we have to know when sample is a very bad sample, then we shouldn't use spinning. Then we should be using actually double density. Otherwise, the sample can get hurt more. So what Farhana said, there can be injury to the plasma membrane. DNA damage, I'm not very sure because DNA damage cannot occur in 10 minutes. Farhana. DNA damage cannot occur in those 7 or 8 minutes. So there's no DNA damage. DNA damage is normally a chronic damage is there. Acute membrane damage can occur. There can be breaking of the plasma membrane, agreed. There can be breaking of the acrosomal membrane, agreed. But there won't be any DNA damage which can be quantified by DFI. ऐसा होता नहीं है 10 मिनट के अंदर. So DNA damage is due to ROS and it occurs over a period of time, not in period of 8 to 10 minutes. So
Oxidative stress, how can affect the sperm motility and sperm health, andro health, sir?
no, once we have the membrane damage, once you have the membrane damage occurring, then they produce certain chemicals. And these chemicals are basically reactive oxygen species, which will repair the damage. And they are the ones which, in case we have large amount of ROS, and we have removed seminal plasma. Seminal plasma contains antioxidants. Here sperms have been separated, so there is no repair going on in them. So these damaged sperms can have lower potential to fertilize. They won't fertilize. So
Hello, sir.
There comes
Is
the
there any other method to separate sperms apart from centrifuge which doesn't cause damage to plasma membrane?
Madam, in case you want to go and watch a movie, you have not even reached the cinema hall till now. You're at your home. You've yet to reach the cinema hall. People are laughing. So don't worry. Don't worry. I've yet to start the class. Start the class. Or sometime probably we'll throw centrifuge machine out in some time. So I'll come to this. Surely I'll come to this, madam. But very good question, Litika. Very good question. And this is the question I want to address today. Litika spoke, no? I think I'm not wrong. I think Litika spoke.
Likita.
Likita,
Thank
where
you,
are
sir.
you from? कहाँ के हो आप?
What,
Andhra?
sir?
Where are you from?
I'm from Karnataka.
Karnataka. You're not our alumni. So, Likita, very, very good question. And the whole of this 69 to 84 in less than 1 year, I'm doing it for this, addressing your question only. So thank you so much for bringing it up.
Okay, thank you, sir.
So I'm just going to cover everything. So second is the swim up method. This is one method which you can use. So Likita, this method is meant for, I'll call it Likita's method. This method you can use. इसमें use कर सकती है. इसमें ROS damage नहीं होता है. There's no ROS damage here because here we take semen sample here and we do medium overlay here. And the sperms will move up. And as they move up, we collect them from here and do our procedure. Simply. You can easily do ICSI in such a sample. So this is rapid isolation. It occurs in barely 5 to 10 minutes. No spinning and works very well. This is a method where we don't have any spinning at all, but this is meant for a very good sample. An ordinary sample, we don't use this. You can use it for ICSI, excellent. IVF, excellent. But for IUI, the sample has to be very good. Good volume also. This one method you can use it. Simple method where we take the semen sample in the tube, overlay with the media, sperms will swim up. And then once they swim up, we have an option to use it directly, or what we can do is we can wash it again and then use it. So it can be simple swim up, or we take the swim up and then we swim up plus wash. This is called simple method of swim up. The other method is that we wash it first. Here, the third method is that we wash the semen sample and then we take the swim. So there are three types of swim ups we do. And I think the only safe method what Likita wanted to brought out is the simple method where we do plain swim. That's all. Once you wash it, the damage will occur. So we get this little small palette here and palette we can use. Now coming to the density gradient media. Now here again my fundamental learning will be that it needs double centrifugation. Double centrifugation. The first wash can be for here we keep the speed at around 1200x and take the time to say 15 minutes because time can increase it because it's got a gradient to come down. But we don't try to increase speed much. More speed can cause problem. So the gradual timing are okay. And this is what we normally get here. We are taking two layers. So we have got a layer of 90. We got a layer of 45. Or we take a layer of 80. Take a layer of 40. Take a layer of 55. Single density. This is called one preparation. Add the semen sample up here, centrifuge. Again, it says 1200 RPM and 20 minutes. Here, I say I'll limit myself to 15 minutes. No, we don't like to spin much. And then you remove the supernatant, you get a palette, and then we wash the palette again for 5 minutes. Here again is washing at 20 minutes. I say never go to more than 5 minutes for second wash. Why do we wash in a double density gradient method? Anyway. Why are we washing in a double density gradient method? What do we wash?
More mortality,
Silica
sir.
particle.
Yes, who said that? Who said this? Who said silica particles?
Yes, sir.
More motile.
Juvie.
You
Sir
come
Juvie.
from Grouting girl.
Yes.
Grouting girl. Okay, we have called you Grouting girl. So great. So we have to remove silica particles coated with selenium. Excellent. So this is one method where we just doing swim up. Just wanted to show to you plain simple swim where we have the semen sample, we have the media, keep it at an angle, but don't keep it for 60 minutes each. We keep it for barely 10 minutes. This is enough for us to get the semen sample. I'm taking some pictures which all of you are using, which are available on the internet. Trying to find the problems with these pictures and telling you what you should not be doing for such a long time. Double density, I keep asking. Today I was examining, today I examined, I think around, must be around 35 MSc embryology people I was trying to examine. A simple question I was asking was that what is interface? I didn't get this answer from many people. What is an interface? And what comes in an interface? Just to tell you that between 90 and 40 or anyone.
Sperm cell division.
Yes. So there are two things. One is called, we get deposit here. Seminal plasma is here with WBCs, and here we get normally immotile sperms. So abnormal immotile sperms, they come probably in interface. This we have to remember. Because this will be a junction. So interface is very important term you must know. So we have to remove this definitely and interface definitely when we are preparing it. So moving ahead, this is a simple what Dr. Abdul said. This is what we have not taken. We have taken 90, we have taken 45, and these are somewhere here is the interface. and then we put the semen sample, and then we get, this is already washed sample, so we're getting 90 here, we got 45 here. This is an interface not seen properly, and this is all the seminal plasma which has to be removed, and here we get a soft pellet. Okay. Now coming to the newer methods. Now coming to newer methods which you wanted to ask. So we have got a method where we are doing just a centrifugation and trying to create some amount of zeta potential. It works on the zeta potential creation. And the zeta potential creation means that we rub the tube. Once we rub the tube in our hand, it develops positive charge. Okay. And the sperms will attach with the positive charge. Good sperms. And bad sperms won't wash. Bad sperms won't stick to the wall of the tube. This is works on the zeta potential, and this is works on that the tube we can charge positively and sperms will go and stick to it. One method. So this is not just under research, though it's a very good method as per even Cochrane, but we don't do it as a routine. Second method is called using HbA binding or ICSI, where we are binding sperms with the hyaluronic acid receptors. Here we are coating the plate with hyaluronic acid and sperms will bind with it. The sperms which bind with it, they are good sperms. There is one way of sperm selection, and it is called petri dish or physiological ICSI. The third method is called using magnetic sperm separation. In this, we are using some sort of a magnet, and we pass these sperms through it, and all these sperms which have got some damage, we are coating it with annexin 5 beads, which has got an iron particle attached to it. They will attach with a magnet, and good sperms will pass through. Just want to cover in very small glimpse that there are these methods, and they are now coming to the max. The max work like this. The max have got, when the sperms are damaged, it will expose phosphatidylserine. Yes. And annexin 5 magnetic spheres will bind with the damaged sperms. And when they pass through the magnet, the bad sperms will bind to the magnet, and only the good sperms will be able to pass through. Simple. For a C2 batch, you'll be hearing it for more than 15-20 minutes when we go to the classes, but that's the way it works for everyone. This is one method which is called magnetic sperm separation. The equipment costs around expensive, around 5 to 8 lakh rupees.
The same like this fax matter.
Same like
Flow cytometry.
But flow cytometry
Fax.
flow cytometry doesn't have clinical application till now. Flow cytometry can do it.
Yes.
But flow cytometry is not, this is an OPD machine, no? So you can keep it in OPD. It's a tabletop machine. It's available in the market. Flow cytometry, you want to buy from BD flow cytometry, it will cost you so many lakhs that you won't earn in the next 10 years. The flow cytometry is something very different. Buy from BD, expensive. The flow cytometry is a very different application. Now, this is a clinical device which is available in our country also, but the kits are very expensive. So, flow cytometry, we use it for research. This one is for clinical application. This is the difference, right? This is called magnetic sperm separation. Then comes to things like microfluidics. Now, this is what is the thing which we were using. The device was called fertile device, and this device is not available in the country anymore. Somehow, post-COVID, the company was shut down or whatever, I don't know. But the lovely device, it was very good for ICSI. It's an ICSI device where you put the sample here, and you can find there are some compartments, there are some obstructions. This works on the microfluidic channel. We used to get good enough sperms for ICSI only. This is meant for ICSI. It works on microfluidic channels. Remember that? It's a microfluidic device. It works on hydrostatic pressure. And these are two different devices. Now, this is a microfluidic device. And this is this device works on the principle of polycarbonate membrane. Okay. Now, laminar current and hydrostatic pressure head was the against the device which came. Second device which we were using. This is for IUI also. You can use it for IVF also. Here we worked upon the hydrostatic potential. So device this was pure microfluidics. This is on hydrostatic pressure, and then it worked on microfluidics channels for which are created here. So this is again not available in our country. So this is the way we had channels, and we could separate all these WBCs and then get the good sperm sample out. Now we come to polycarbonate membrane devices. This is a zymote device. It works on the concept of a polycarbonate membrane. And here you can see that. So can someone tell me what is the hole size in the polycarbonate membrane?
8 micrometers.
8 micrometer. Beautiful. Who said that?
Main cause.
Good. So we take our syringe and we put in this hole inlet here.